All right, so let's take a look at our focus activity. We now have the exit ticket out of the way. I'll get those in and I'll get those back to you tomorrow. Don't forget, your homework is due tomorrow. We'll grade that and then we'll continue with the review. Also, Thursday, this is the big item. You have the exam. Okay, so it's going to cover derivatives, limits. Okay, it's going to have the power rule on there. It's also going to have writing the equation of tangent lines, all that good stuff. Okay. So let's take a look at number 5 here. And this one is a problem coming off of that released exam from 2014 that I gave you. Okay, so it's number 5. It says, consider the graph of the function y equals f of x defined below. Okay, so this curve represents f, and I've got all these points on here. It looks like 8 of them. All right, so here's what it says. Write down all the labeled points on the curve that are local maximum points. Now, what do you notice about the number of marks? Yeah, when it says 1 mark, you should not have to do any work. You should just see the answer basically in front of you, whether it's coming from a graph or a table, whatever the case is. So we want all the local maximum points. What is it asking for? Okay, now when we hear those words, maximum and minimum, what elements do you think it refers to? Is it going to refer to the x's in the domain or the y's in the range? It refers to the y's. You're talking about the largest y value and the smallest y value, the maximum and the minimum. But as we see here with these curves here, sometimes we have on a given interval, if I look at a particular region of the graph, we can have what's called a local maximum or a local minimum. It's not the largest, but in a particular region or interval, it is the largest in that interval. Okay. So does this one have what we refer to as an absolute maximum? One where there's guaranteed there is a y value that is the largest, no other y value is larger than it. Okay, there we go. So that would be what? Point F. Now, even if you have one that is a absolute maximum, or even an absolute minimum for that matter, it can also be referred to as a local maximum or a local minimum. Okay, so for this one here, we're definitely going to go ahead and put F, but is there any other point on there that would kind of fit what we were talking about? B. Both of those would be considered local maximums. Okay, so for here, I'm going to go ahead and put BF. The order does not matter. I would say probably just alphabetical, but I don't think that's going to be an issue. Okay. All right. Sydney, if I get you to turn that in. That was 12 minutes, yeah? All right. Too bad we don't have two F's to be BFF. I'm just trying to get you guys to laugh. It's like this week we're kind of dragging. I don't know. We okay? A lot of good feedback. Okay. Okay. All right. All right. Well, let's try B, where the function attains its least value. So we could refer to that as the absolute minimum. In fact, is there one that's the absolute lowest? H. Okay. Now, think about what I was saying a second ago. H could also be referred to as a local minimum. Could there be another point that I could say is a local minimum? I would say D. That's absolutely right. So if you look at specific intervals, on that interval, it could be the largest for that particular region, or the largest or smallest overall. Okay. So for this next one, I am going to go ahead and put H. Yes.
What are the intervals?
And that's the thing. Sometimes the intervals will be defined and sometimes they're not going to be, like in this case. It's just really going more off the definition than anything else. So maybe not the entire interval, maybe if I were to take it from here to here. Okay. And I'm just kind of guessing.
So on one where it doesn't give us the intervals specifically, should we assume that like the interval is between where it crosses the x-axis if it's
That's probably a good idea. That's probably a good idea. Mm-hmm. All right, because that's where the function is going to change sign. Okay, so I think that'd probably be your best bet. Okay. What did C say? Where the function attains its greatest value. We just referred to that as the absolute maximum, and that was what? F. Okay, so I'm going to come back over here, F. Where the gradient, the slope of the tangent to the curve is positive. Okay. How do I figure out where that's going to happen? Okay, what's that? You say point E? Point E is absolutely one of them. Now remember, what we're asked about here is the slope of a tangent line, right? Well, the tangent line is only going to cross it in how many locations? Only one location. Okay, so for point E right here, what Michelle's talking about, I can go ahead and draw a line, and I'm not drawing a very good line at all, but imagine, of course it doesn't go forever because we're not going to intersect it again to a secant point, but just imagine this line right here. If I were to draw the tangent line, it would have to have a positive slope. It would have to rise to the right. So that's one location. Would, for example, G fit that category? No, because that's a horrible line. But you get the fact that G, okay, on the outside where it is, that would fall to the right. So that would be a negative. All right, so is there any other place where I could draw a tangent line and get a positive? A, absolutely. Okay. What about C? C would be a negative. Okay, we already said G would be a negative. H, because the function was going down like that, is also out. What about B and D?
Those be horizontal.
That's exactly right. We were referring to those a little while ago as a local max and a local min. So if it represents like a peak, or think the top of a mountain, okay, there we go. And you remember we did a problem the other day where we set the derivative equal to 0 because we were wanting to know where those maxes and mins were. You guys remember that? Okay, that was a good way of doing it. All right, so we ended up with A and E on this one. Okay, and then we have our last one here, where f is greater than 0 and f prime is less than 0. Do you guys want to try this on your own? I'll give you 30 seconds and then we can do it together. Kind of give you the opportunity. Where f is greater than 0, but the derivative is less than 0. Okay, so let me erase this. Where f is positive, but the derivative is negative. Okay, so don't say it out loud, but the questions we're thinking, where would the function be positive? How do I know? Okay, how do I know where the derivative would be negative? Okay, anybody think they know what it would be? Okay, what do you think, Spencer? It's the only one that works. Okay, so let's talk about the first one. What does it mean when we say the function is greater than 0? There you go. Remember, f of x is the y value, right? You remember how it's interchangeable? Okay, so I would only want to look at the regions of the graph that were above the x-axis. Okay, because you remember this is where y is 0, so above it's positive, below it's negative. So I'm only interested in those regions. Now let's look at the second part of it, where the derivative is less than 0. Okay, well, what's the derivative been providing us? The slope of tangent lines, right? So where would I get a negative slope? Again, pretend it hits that point. Okay, C would be the only location. A would be a positive, E is a positive, B would be 0, as would F. Okay, so the only one that works here has got to be point C. All right. Now this one was worth 2 marks. So like I said, a good rule of thumb would probably be to go ahead and show something. I mean, there's no work. If anything, I might go ahead, just to let the people know again what I was referring to, maybe bold the top portion there, go ahead and draw the tangent line. I mean, just anything to indicate what your thought process was. Okay. All right, good. Now, these are going to be due tomorrow, so we won't worry about them today. We'll just go ahead and turn them in tomorrow, or if we have a few minutes. I do want to go ahead and try to get away with one more before we leave. Okay, where was the review here? Okay. Let's see here. Let's go back to number 2, a good old scatter plot problem. Okay. So it says the diagram below shows the marks scored by pupils in a French test and a German test. The mean score of the French test is 29 and the German test is 31. Okay, so A, describe the relationship between the marks scored in the two sets. So really they're looking for one of two words. What do you think I'm referring to? How do we typically describe the way these points would fall? Positive or negative. So here the correlation is positive. They seem to be rising to the right, correct? So I would say positive correlation. Okay. On the graph, mark the point M, which represents the mean of the distribution. So what we're talking about is the grand mean. So we don't have the data itself, but it does give me everything I need because the French is the horizontal. That's the one that's going to go first, 29. And then we have the mean for the German test is 31. Okay. So let's see here, 29, 31. I think that'd be right there. Would you guys agree? That would be the grand mean for the data. Okay, the average of all the French exams, the average of all the German exams. Okay. Oui. How do you say yes in German? Is it da? Or what is it? Da. Da. Because with German, you got to speak a little more forceful. Okay. Anyways, draw a suitable line of best fit. Now, when you go ahead and draw your line of best fit, you want to make sure what? That it goes through that grand mean. Okay. Now here, like yesterday, we don't have enough information to kind of get an idea where my y-intercept would occur. So we're going to have to just kind of eyeball it the best we can. I'm thinking maybe something like that. However you draw your line, remember you want to try to hit as many points as possible with as many points above as below. Okay. Roughly. So maybe I'm a little off. I mean, I hit the point actually this time. That's good, right? Because every other time today I couldn't hit the point. All right. Now it says Idris scored 32 marks on the French test. Use your graph to estimate the mark Idris scored on the German test. So what do I do here? Yes. Oh, I'm just following the points. I mean, it may go through the origin, but I'm just trying to follow the pattern that I see. It looks more likely to me that it kind of does this. I don't know. Do you want me to change it? I mean, I just drew the line. Okay. All right, so how am I going to figure out D?
Where on the line of best fit?
And actually, you know, come to think of it, Haley was asking why wouldn't it go through the origin? You know what? In this case, I would think it would have to. Because what's the lowest you can get on a test? It would be 0. Yeah, I would agree with that. There we go. There you go. So if you see something like that, you know, definitely say something because, you know, it's never like me to make a mistake, right? It's really quiet in here.
So are there other cases where it wouldn't go through the origin?
You know, I guess it depends on what your quantities are. But here, since you're talking about tests, I mean, it makes sense that you could. I've had students score 0s before, so it's possible. Yes.
Does it have to go through the origin though? Because I mean, you're not guaranteed. Like,
Yeah, I mean, that's the only thing. I mean, I wasn't even thinking about the fact they were tests. I just drew the line with the data. So you remember the line that I just drew? Does it look better like that? Which one do you think fits it better? The one I had originally or the one starting at 0? It does? Let's see. I got 1, 2, 3, 4, 5 here. I got 1, 2, and it looks like it's hitting 1, 2, 3, 4. I don't know. Well, let's actually see. Let's go ahead and draw the line both ways. Okay. And the question was, okay, use a graph to estimate Idris' score on the German test. So let's do this. I'm running out of time here. So 32, so I'm going to go to 32, and I'm going to go straight up. There's that one. And let me go ahead and choose purple. If I go to 32 here, so actually, I mean, they're pretty comparable to each other. Okay. Maybe we can go ahead and take the difference of the two. Looks like one is 33, maybe the other is 35, so 34. Okay. All right, bye. Everybody's out here. Does that make sense? Okay. All right. Okay, so I will see you guys tomorrow.